Hey guys, welcome back to my CCNA 20301 course. Patrice is here, and in this video I'll be talking about switching concepts. Are you ready? Let's get started. Before we jump on the main topic, we have to review a bit of history. There are two types of topologies in one sense. Physical topology, which refers to how we physically connect our devices, and logical topology, which refers to how data flow in our networks. In the star topology, if we use a hub as the central location, the physical topology seems to be like a highway that multiple people or devices can connect to the network and transfer data simultaneously. However, it is not true. Hub is a layer 1 device, and whenever a hub receives a signal from a port or interface, regenerates it and sends it to all other ports except the sender port. Hub uses a shared media or a bus in the back end, so it does look like a one-way road. And if two cars come through this road, they will definitely collide. Here we learn a new term, collision domain. Collision domain simply points to all devices that will collide with your sending data if they send their data at the same time as you. With hubs, no matter how many of them you got in your network, you'll have a single collision domain. So any two devices anywhere in the network send data at the same time, that data will collide. So there should be a way to handle these situations. Ethernet uses an algorithm called SESMA-CD, which stands for Carrier Sense Multiple Access with Collision Detection. This algorithm has 4 simple steps. First, listen to the media and make sure it is not busy. If not, second, send your data. If your data gets collided and you receive the jamming signal, 3, step back, set a random timer and start over. The switches brought a higher level of smartness to the networks. Switch is a layer 2 device that makes its decisions based on MAC addresses. This gives us 2 major benefits. First, security. With hub, all devices in the network will receive a copy of all transferred data in the network, which might be including information like credentials and other confidential information. And second, performance. Each switch port is a separate collision domain, so no simultaneous frames will collide from different ports, and this will increase the network performance significantly. Switch makes this decision based on the information which is stored in the MAC address table. This table is also known as bridge table or content addressable memory, or CAM in Cisco terms. This table has different fields, but for simplicity I just show you the 2 most important ones. When a frame receives at a specific port, the switch looks up this table for the destination MAC address and sends the frame to the desired destination port only. But the question is, how does this table fall? Whenever a switch receives a frame other than looking up the MAC address table and forwarding the frame to the right destination port, it checks the source MAC address as well, and then learns the MAC address and put it in the MAC address table. Another question that may have come to your mind is, what if the switch cannot find the destination MAC address of a frame in the MAC address table? In these situations, switch broadcasts the frame to all ports except the sender, and this process is called flooding, and it happens for unknown unicast messages. But how a switch broadcasts a message to all ports? To send a frame to all ports, Switch uses a predefined MAC address for broadcast messages, and that MAC address is all Fs. I want to take this opportunity and introduce you to another specific MAC address, and that is multicast address. All multicast addresses start with 01005E, and the rest will be determined by the multicast group address. The other question is, what is the capacity of this MAC address table and how many entries are possible? The answer depends on the platform. Each Cisco switch has a different capacity for this table, but definitely this space is not infinite. In the next video, I'll show you how you can figure out the size of this table by running a command. So, what should a switch do when it reaches the point that there is no more capacity for newcomers? Switch will consider a timer per entry. This timer is called Inactivity Timer. Whenever switch receives a frame from a sender, it resets the sender's entry in the table. Let's assume a device is disconnected from the network or its NIC has been changed and that NIC is not in the network anymore, so it won't send any frame for a certain amount of time. And the inactivity timer gets older and older. If the timer's entry reaches out to a certain point and the switch does not receive any new frame from it, it will delete the entry. And with this approach, switch controls the MAC address table size. Hackers use this vulnerability and bombarding the switches with fake MAC addresses and create an overflow for MAC address table. If that happens and the MAC address table overflows, the switch will simply become a hub in terms of frame forwarding and will broadcast all messages. Here is the other term that is normally coming side by side to the collision domain, and it is broadcast domain. Broadcast domain determines if you send a broadcast message, who will receive it. Hubs and switches create a single broadcast domain, no matter how many of them you use in your network. Routers are the only devices that can break the broadcast domains. These are the CCNA topics that we have covered in this video: MAC address learning and aging, frame switching, frame flooding, and MAC address table. In the next video, I'll be talking about VLAN concepts. I wish you enjoyed this video. See you in the next videos and thanks for watching.